To show this inequality is true when n is bigger than or equal to 3, here we denote Sn as this sum. Okay, so first let's look into this. So 1 minus 1 over n to the power of n, we denote as an. This sequence, okay, this sequence, let me see. Rewrite it into 1 over n minus 1 over. So n over n minus 1 to the power of n. Right? Same thing, right? Take it to reciprocal. So separate the fractions. Right? So n minus 1 plus 1. So 1 plus 1 over n minus 1 to the power of n. Right? So obviously we just say 1 over 1 plus 1 over 1 minus n to the power of n minus 1 times 1 plus 1 over n minus 1. Obviously approaching 1 over e. So here's my claim. An is increasingly approaching 1 over e. Here's how. I'm going to study Bn, that is 1 plus 1 over n to the power of n plus 1. Obviously approaching e. Right, I'm going to claim Bn is decreasing. Here's how. First of all, Bn, right, we rewrite it into reciprocal. Right? N over n plus 1 to the power of n plus 1. Okay, separate the fraction. 1 over n plus 1 minus 1. So 1 minus 1 over n plus 1 to the power of n plus 1. Okay, I'm going to rewrite it into 1 minus 1 over n plus 1 multiply itself. 1 minus 1 over n plus 1 times 1. Here we have n plus 1, many of them. So here we have n plus 2 factors, including the 1 here. Right, greater than AM-GM inequality. Right? We take it reciprocal, therefore it's greater than. Okay, cannot be equal to, because 1 cannot equal to this. All right, so 1 over arithmetic mean n plus 2. So sum of those factors. All right, first n plus 1 times this factor. Turns out to be n, and we plus 1 to the power of here. Right here we don't take the root. Right, geometric mean there's no root here, so we raised power of n plus 2 in here. All right, so that is rewrite into reciprocal. Is n plus 2 over n plus 1 to the power of n plus 2. All right, that is separate fractions. 1 plus 1 over n plus 1 to the power of n plus 2. All right, what's the pattern here? All right, there's Bn, right? So this must be Bn plus 1. So in conclusion, greater than, right? So in conclusion, Bn is greater than Bn plus 1. So obviously, yes, Bn decreasing. But when you look at here, right, here is n minus 1. There's n, right? There's n plus 1. So obviously, 1 over Bn minus 1. Right? Bn is decreasing, so this must be increasing. In other words, An is really increasing So far, we've shown that this sequence is increasingly approaching 1 over e. Right? So that means a2 is less than a3, all the way less than an. Of course, an is less than 1 over e. Right? But what's a2? Right? a2 is just half to the power of 1 over 4. So this is easy. So this is my first rough estimation. I'm going to use this bounds, lower bound, upper bound. Then I'm going to make a rough estimation of Sn. Right, that is 3. Let me just write down this term and last term. This time my rough estimation of upper bound is less than equal to less than replace every term with this term, right? Because n is greater than or equal to 3, right? So this term, this term, this term, right? So here I should have n minus 1 terms and last term. Right, so that should look like, so n minus 1 times each term plus last term. Right? So combine those first two terms, right? These two. So that should n minus 1 to the power of n plus n to the power of n. Of course, n minus 1 less than n, right? So n to the power of n plus n to the power of n. So that is 2n to the power of n, right? So this is the rough estimate, rough upper bound, right, of Sn, right? No larger than this. So, okay, let me just write it down. Sn is less than 2 times n to the power of n. So, in other words, if it's Sn minus 1, it has to be less than 2 times n minus 1 to the power of n minus 1. Right, same logic, right? Just change the subscript. Now, this is a quite nice estimation, because now I'm going to use this to link to this sequence, right? Looks like I have to divide everything by n, because n now is on the bottom. I divide everything by n. Perhaps I have to divide by n to the power of n minus 1, right? Copy down this. Of course, have to multiply by n to the power of n minus 1, right? Same thing. Combine those two, right? 2 times n to the power of n minus 1. N minus 1 to the power of n minus 1. 2 times n to the power of n minus 1 times 1 minus 1 over n to the power of n minus 1. Right? To make up this power, make it n, I have to right, for example, if I want to make up powers n. Of course, I have to, first of all, I multiply the reciprocal of this, right? So minus 1. So the reciprocal of this is what? I think it's n over n minus 1. All right, so this is good. So this n goes with this. 2 times n to the power of n. I move this n minus 1. Right. Copy this. 1 minus 1 over n to the power of n. And so n minus 1, 2 times n to the power of n. So again, this is actually an. Right, I've successfully linked this to an. But let's see. Okay, so let's see. So far, like I said, first I proven Sn is less than 2 times n to the power of n. So same logic. Sn minus 1 less than 2 times n minus 1 to the power of n minus 1. So that equal to that. So actually Sn minus 1 less than this, right? So now I can estimate Sn, right? Sn is Sn minus 1 plus n to the power of n. Right? That's the same thing. So Sn already smaller than that, right? So smaller than n minus 1. 2 times n to the power of n times an, right? Plus n to the power of n. Right, so this is good. So which means here I can further loosen an. Like I said, an here. First, I prove an is increasingly approaching, right? So in other words, an has to be less than 1 over e, right? So loosen it by that. So less than n minus 1, 2 times n to the power times 1 over e plus n to the power of n. Right? So this time I can just factor out n to the power of n, right? I'm left with just, here's 1 plus I think 2 e times n minus 1. Okay? Looks right. So that's the right-hand side, right? Inequality. Sn less than n to the power times 1 plus 2 over e times n minus 1. Right? Same thing. Okay. So the left-hand side inequality, how do we know that? Okay. So first of all, like Sn, so here we can loosen Sn just a little bit and get rid of the previous, this term. We only keep last 2 terms, right? Make it a little bit smaller. So n minus 1 to the power of n minus 1 plus n to the power of n, right? Since n is greater than or equal to 3, so this a little bit smaller, right? Make it a little bit smaller. So like I said, so this part, right? This part looks like this part without the 2, right? So here is 2 times this part, right? There I don't have 2, right? So looks like, yes, this part without the 2. So that is equal to n minus 1 times n to n times an plus n to n. Right? But an is bigger than 1 over 4. right? Bigger than n, then 4 times n minus 1 plus n to n, right? That is n to n factored out. 1 plus 1 over 4 times n minus 1. Right, that's exactly the left-hand side. Right? Exactly.